All right, so here's our problem statement. A square pyramid is increasing its height of the base by 6 meters per minute and decreasing its height at a rate of 1 meter per minute. At a certain time, the side base has a length 3 meters and the height is 9 meters. What is the rate of change of the volume of this pyramid? Okay, so in this problem statement, we weren't given like a figure of what is being described to us. So I went ahead and drew the figure. It's a square pyramid. So hope you don't judge my art skills or my art abilities. I tried drawing the square pyramid as best as I can. So I went ahead and drew this figure right here. So we have a square pyramid. This is our square base down here, right at the bottom of the pyramid. And we have side lengths, each b, because it's a square pyramid. So this length is b, this length is b all around. And then the height of the pyramid is this top of the vertex where all of the triangles meet to the bottom of the pyramid. So this is h right here. I labeled that as h. So now we have to recall what is the volume of this square pyramid? All right, well, let's recall the volume of the square pyramid. I'm going to write this as V. Now, the volume of the square pyramid is just the area of our square right here. So it's V squared, because the area of a square, times H over 3. That is the volume of the square pyramid. Okay. So we want to find what is the rate of change of the volume of this pyramid. So the rate of change of the volume is actually going to be, we're going to have to differentiate V. In other words, taking the derivative of the volume. Okay? So let's, on this side, I'm going to write all the stuff that's been given to us. So if I go ahead and read this whole statement again, kind of skim through it. So the pyramid is increasing its side by 6 meters per minute. So it's increasing its side of the base. So this is the rate of change of the base, not the base, it's the rate of change of the base. So the rate of change I'm going to denote as dB. So that's 6 meters per minute. And I wrote 6 minutes. It's actually 6 meters per minute. 6 meters per minute. And the height is decreasing, keyword, at a rate of 1 meter per minute. So the rate of change of the height, in other words, is 1 meter per minute. Now, keep in mind, when the statement says that at the rate of which something is changing is decreasing, it's a negative value. So because our height is decreasing every minute, we are going to have a shortage of height in which the height is actually going down in its value. So that's why we have the negative here in the front. So we have dB, we have dH given to us. Now at a certain instant, the side base has a length at 3 meters. So our base is going to be 3 meters and our height is going to be 9 meters. All right. Now we want to know what dV is. Okay, we don't know what that is, and I'll write that here too. dV, what are you? Okay, let's go ahead and write the volume of the square pyramid again. I'm going to write it down here. And we're going to go ahead and differentiate, take the derivative of this volume. So now with respect to time, because time is the variable in which we are differentiating with respect to. So let's go ahead and find dV. So we take the derivative of V, which is dV on the left side of the equation. Now we need to take the derivative of this right side of the equation. Now we have two variables that we need to differentiate. So what does that sound like to you? Well, it sounds like a product rule, right? We have two variables, two separate things that we need to differentiate, and they're multipliers of each other. So it does sound like the product rule, and we are going to need to use the product rule in this case. Okay, so let's go ahead and do that. So how are we going to go about doing this? Well, first of all, I see that this whole expression is divided by 3. So by convention, anything that has like a constant or a coefficient in front, you can always bring that out to make it a little bit easier. So this is, I can rewrite it as 1/3 times b squared times h. So I'm just going to bring the 1/3 out here. We don't need to really bother with that right now as we go ahead and take the derivative of this product right here. So let's go ahead and take the derivative of the product. Now recall the product rule. It's the derivative of the first term times the second term plus the first term times the derivative of the second term. All right. So let's go ahead and take the derivative of the first term. So it should be 2b. We'll drop the exponent down, subtract 1 from it. And since we're taking the derivative of this with respect to time, we do need to multiply it by dB, because that's the rate of change of the base. In other words, how much is the base changing over time? All right, so that's this expression right here. And then, of course, we need to multiply by our h, because it's the derivative of the first term times the second term. Now we're going to add the first term right here. We leave that alone. Put that right there. Take the derivative of our second term. So what's the derivative of h? Well, it's technically 1 times the derivative of h, which is dh dt, or you can just write it as dh, because we know that it is the rate at which the height is increasing / decreasing with respect to time. And in this case, it's decreasing with respect to time. All right, so this is our derivative of the volume of the square pyramid. Now, we want to know what dV is. So how are we going to do that? Well, do we know all of these values? Well, we do. We have h. Okay, we do need h. Now, we have b. We have dH and dB. So we do have all these known values. So we can go ahead and plug and chug our known values. So over here, we're going to have 1/3 times, okay, it's going to be 2 times our base. So our base, in this case, is going to be 3 meters times the dB. So dB we said to be 6 meters times our height, which is 9 meters, plus, okay, now b squared. So what is our b? We said that is 3 meters. 3 meters, and we're squaring that, times dH, which is -1. So don't forget about the negative. All right. And then, of course, let's close the brackets here. All right, now let's go ahead and compute this. I'm going to go ahead and pop in my calculator and try to evaluate this. So we're going to have 6 times 2 times 3 times 9. And then we're going to subtract that with 9 divided by 3. And we should end up getting this as a result. So it should be 105 meters cubed. That's the volume and the rate of change of that. So meters cubed per minute. So don't forget, when you go ahead and use your calculator to evaluate this, you get your value for your dV or whatever it is that you're solving for. And then also it's important to include units too, because you don't know what the units are if you just put 105 or 2. You need to also specify the units. So the rate of change at which the volume is increasing / decreasing. In this case, it's increasing because we ended up with the positive value. So we know that this is increasing the volume by 105 meters cubed per minute.